Hi guys, we are switching gears. We are switching from two-dimensional figures and area to 3D figures and surface area and volume. So we're going to start with prisms today, and what makes a prism unique is that it has two congruent and parallel bases. Okay. And they can either be right or oblique. So right is exactly how you think of right angles. They're perpendicular, they stand up straight. Oblique looks like these figures on the right here where they're just a little slanted. Now a right prism has two parallel and congruent bases, and the remaining lateral faces are all rectangles. So in this figure on the left, I've got my bases that are across from each other. They're parallel, they're congruent, and all the other faces, these lateral faces that go up and down around the side, those are all going to be rectangles. Whereas in an oblique prism, the sides going around are all parallelograms. So here are a few more examples of prisms, and a prism gets named after the shape of its base. So this one would be a triangular prism. This has 5 sides, so it's a pentagonal prism. We have rectangular prisms. You can have any figure as the base. And again, the lateral faces are all the polygons that are not bases, so think of like the sides. And we also have the altitude, and the altitude has to be perpendicular measurement joining the planes of the bases. So here it would go from base to base, base to base, and so on. Okay. So the first measurement we're talking about today is surface area. Now, surface area is the total area of all the faces and all the bases. Think about it as in terms of wrapping a gift. The amount of wrapping paper you would need to cover something, that's the surface area. Here's our formula we're going to use, that the surface area is equal to the perimeter of the base times the height of our figure, plus we need the area of both of the bases, so 2 times b, where our capital B is the area of the base. Sometimes you might be asked for just lateral surface area. That's the area of the figure just without the bases. So it's just the first part of our equation, the perimeter times the height. Okay, here's our first example we're going to work through. It's a rectangular prism. And with a rectangular prism, it kind of doesn't matter what you choose to be your bases as long as you're consistent. So I'm going to use the top and bottom of my figure as my bases, and when I look at my formula, I need the perimeter of the bases times the height. So my perimeter would be 7 plus 13 and 13 times the height of the figure, so this perpendicular distance here, which is 9, plus I still need the area of my two bases. So 2 times, this would be length and width, so 7 times 13. So I went through all my steps just to simplify. Now surface area is just like area, so our units of feet here are still just squared. Nothing is special about surface area in terms of units, but it's feet squared. Okay, here's our second example. This is a triangular prism, and I've highlighted in pink the triangular bases. So remember, the bases are congruent and parallel. So these are the things that stand flat across from each other. So my surface area is going to be the perimeter of my base, which is the perimeter of the triangle. So I've got a side of 5, 12, and this slant is equal to this, so it's 10. And the height refers to the height of the prism. So it's going to be the distance that connects the bases. So that's going to be a 3. Plus, I need 2 times the area of the base. So now I'm calculating just the area of this triangle. And we remember the area of a triangle is 1/2 base times height. Now the base of my triangle is 12, and the height of just the triangle is 4.1. So I've got 1/2 times 12 times 4.1. So again, here's my final answer. I've got 130.2 kilometers squared. Why don't you give another one a try? Now for this one, our bases are these trapezoids. that are across from each other. So you'll need area of a trapezoid, and the height between the bases is 15, but the height of the trapezoid is 12. One more for you to try. Now our bases are the triangles that are across from each other, and be careful when deciding in your formula the height of the prism, again the distance between the bases, versus the height of your base, just the triangles. So here's the final answer of our triangular prism. And one more example to do by yourself. This one you have to work backwards. You're given the surface area is 272. You have to find the length. All right, here's the final answer for this one. It would have been 8 inches for the length of the cereal box. Now switching gears to volume. Volume is the amount of space that an object takes, or how much you could fill something with. And the formula for volume of a prism is going to be the area of the base times the height between the bases. So again, it's the height of the actual prism. So in a rectangular prism, these are the easy ones, because if we're sticking with our formula, volume equals the area of the base times the height, this really turns into length times width times height. And again, it kind of doesn't matter in a rectangular prism which rectangle you choose as the base. So when I plug in my 3 dimensions, I got 9 times 17 times 24 for 3,672. And volume is measured in units cubed. So my final answer will be centimeters cubed for this one. Okay, we're going to solve volume for this triangular prism here. Now I wrote out my formula of area of the base times the height. Now I filled in the formula for area of my triangular base, which would be 1/2 base times height. This is specific to the triangle, so the h here is the height of just my base, which would be 28 kilometers. Whereas this h from my original formula is the height of the prism, so that's the distance between my two bases. Now before I solve for the area of my base, which is my triangle, I am missing a measurement. I do not have my base measurement here, which means I have to do some Pythagorean theorem to solve for that. Okay, so on the left over here, I used Pythagorean theorem to figure out the base of just my triangle, and I got about 16.5. I brought that over here to my volume formula, and everything written here first, this is the area of just my triangle. So 1/2 times the base of the triangle, 16.5, times the height of the triangle, which is 28. All of that gets multiplied by the 31 because that's the height of the prism. When we simplify everything multiplied out, I get about 7,161 kilometers cubed. Okay, here's a trapezoidal prism for you to try to find volume of. I've set you up with the formula over here, given the formula for the area of a trapezoid. Remember, you need the height of just the base, so you might need to do some Pythagorean theorem again. And the big H on the outside, that's the height of our prism, so between the two bases. Okay, before you get too far, double check the height of your trapezoid, this green line right here. You should have solved for using Pythagorean theorem and gotten 27. Now, I set up a little triangle on this side of my base, and I found that this little segment in purple here is about 14.4. And the way I did that was this full length is 39.4, and just to where this green line meets would have been 25. So the difference would leave me with 14.4. Now use that to continue and solve for the total volume of our prism. Okay, here's the final answer for that one, and one more practice for you to try on your own, another trapezoid. Okay, here's the last answer for you guys. Remember, reach out if you have questions.